All right, so one of the very important concept is the concept of phasor. And in the phasor is nothing but a rotating vector. And it represents the alternating quantities like voltage and current. But a very important part of the phasor representation is the angular frequency of the signal. So a phasor which is represented with the help of the maximum amplitude. Maximum amplitude means the highest, the peak value, V naught, V peak, I naught, I peak, also has a frequency associated with it. So while we make the phasor with the help of angle, which is written alongside with the maximum value, we should also ensure that we never forget that the signal has a frequency, right? So it is rotating. And if you understand that phasor is rotating also, not only it's a value which is represented, but also rotates. From that comes the concept of that the projection of this rotating vector tells you the instantaneous value of the quantity it represents. So if you have a phasor which is rotating with angular frequency omega, it is the voltage being represented. If you want to represent the instantaneous value of that voltage, then use the projection of that voltage on the axis to find that out. For details, go through my next video, which will follow this, and you can understand phasors in detail and the rotating nature of the phasor. Thank you very much. All right, so just a quick recall of the concept of phasor. The first part of the phasor is Im. So what we do, we draw a circle whose radius is Im, right? So if you see the equation, it's I is equal to I max sine omega t. That equation tells us the frequency. So the circle we draw and the vector we draw OP, have these being used. So you can see the OP is moving in an anti-clockwise direction with the angular velocity of omega radians, and the vertical projection of OP is OM and is given by OP sine theta. You can see on the right hand side. Now compare this with the equation I is equal to I max sine omega t. And so this circle, which is drawn with the help of the phasor OP, the vertical projection OM is the sine omega t part of it, and the length of the radius is Im. So this phasor which is moving, has a projection on y-axis given by I max sine omega t, and therefore this phasor actually represents the equation or an alternating quantity, because the projection on the y-axis is same as the equation. OP sine theta, theta is given by omega t. But there is another part to this, which is angle 0, which I'll talk about in my next video. All right, so by now we know that alternating quantities can be represented using the equation, using a waveform, and using a phasor. I think equation and waveform are pretty straightforward because it's just an equation and a sine or a cosine graph. So waveform and equations are not difficult. Now let's focus on the phasor representation. If you see this diagram, you see the equation is I is equal to I max sine omega t. Now this is the equation form of the alternating quantity. If we convert this into the phasor form of the the equation, the phasor form is written as I is equal to Im angle 0. I will elaborate on what it means, but you see the phasor form is so different. It just has a maxima value and it has an angle, which we will talk about. What angle is 0 here? Thank you. All right, so let's try and understand more about the whole concept of phasor. And if you look into the whole explanation, you have taken the length of current as Im, that is represented by OP, and at some instant OP is projecting a vertical component on the y-axis as OM. So you can see OP sine theta mentioned. And what you see is that the OP is rotating with velocity omega radians per second and is following a circular trajectory and is actually moving in anti-clockwise direction. So OP is the length of the phasor. If you see the equation of the phasor as Im angle 0, OP represents Im part of the phasor equation. So it's basically a line which is moving with angular velocity omega written in the equation form in the anti-clockwise direction, and the length of this circle or the radius of this circle is Im. So this OP is the phasor representation of the current. We haven't talked about angle 0, and in the next video we will talk about the angle 0 of the phasor part.